Chunxu Tang from Twitter. Today, Beinan, Wang from Alluxio and I would like to give you folks a tour of Presto Iceberg Connector, which is used to empower Presto queries on huge analytic datasets. The structure of this presentation will be two sections. In the first section, I would like to first give you folks an overview of the Apache Iceberg, what it's used for and what it is. And then I will also give you folks an overview of the architectural design of the Presto Iceberg Connector. And then I will show you some practical examples of how to use this connector to query Iceberg through Presto. And then in the second section, Beinan will talk more about the latest features of the development of this connector. And also at the same time, he would like to deep dive into this internal mechanisms of this latest features. So let's begin. First of all, I would like to give you folks a review of the Apache Iceberg, what it is and what it used for. Iceberg is an open table format for huge analytic datasets. It has some very nice features that are welcomed at Twitter. For example, Schema Evolution, which indicates that the schema can be changed over time, and the Iceberg as an open table format can still provide a consistent interface for queries. Also, it has some other nice features like hidden partitioning, partition layout evolution, time travel, version rollback, etc. And then here is the why we would like to Iceberg and what is it used for. For Iceberg, the main purpose is to transition the lake from files to tables. Traditionally, we have different data files, like say ORC files or Parquet files. And then we have different SQL engines like Hive, Presto, or Spark. At this time, we could use the SQL engines to query data stored in these data files. And Iceberg sits between the SQL engines and those data files and provide a table abstraction. In that case, we can just use the SQL engines to query the dataset just like query tables. And then we have the Presto Iceberg connector, in which could provide us the query mechanism on Iceberg tables in Presto. And here I would like to emphasize a bit, talk about a bit more about the schema evolution mechanism, which is a very important feature in Iceberg. As the time goes, usually the schema will change. Like sometimes we may want to add a new column, or like say drop a column, or rename a column, or update a column, including say widening the type of a column, structure field, map key, map value, or list element, or reorder the data set, the columns. So this is a schema evolution which is provided by Iceberg. And with the Presto Iceberg connector, we could enjoy this nice feature. And then later on, I will show you in some following slides, I will also show you folks some details about like how to use Presto Iceberg connector to get this feature. And here is the high-level architectural design of the Presto Iceberg connector regarding the write path and the read path. On the left side, it is the design of the write path. Suppose that the user sends a CTAS query to the Presto cluster. The CTAS query is create table as select. And then the first step is the Presto cluster will load the data from data source. And then it will write metadata to a metastore. The metastore here could be, say, a Hive metastore or a native folder. The native folder mechanism is a new feature implemented by Jack Ye from AWS. Later, Beinan will talk more internal details of this design. And then the third step is to write the data files into data sink, like HDFS or GCS. So this is the mechanism of the write path. On the right side, this is the design of the read path, which is even more straightforward. Here, the user first sends a SQL query to the Presto cluster, and then the cluster will load metadata from the metastore, which could be the high metastore or native folder mechanism. And then with the metadata information, it will load data from HDFS or GCS. So this is the high-level design of the Presto Iceberg connector. And then here, I would like to show you folks some practical examples of how to use the Presto Iceberg connector to query dataset through Iceberg. So this very first example is about how to create some new tables through the connector. All the examples here are based on the TPCH benchmark, and all examples are written in Zeppelin. Zeppelin is a web-based notebook service, which is quite similar to Jupyter Notebook. A very nice feature of Zeppelin is that we can directly write some SQL queries in some paragraphs, and then run these queries and directly get the query results, which could be shown under the paragraph. And then we can also visualize the result with some nice visualization mechanisms. So here there are two SQL statements which are create table if not exist as select from. So here I would like to create two new tables based on the nation table and the customer table in the TPCH benchmark. And then just use this two SQL statements to create these two new tables. So this is about the table creation. And then after the two tables are created, I would like to run some SQL queries on the two tables. So here, this is a SQL statement related to inner join that I would like to join the two tables together based on the nation key column and return the results. So here you can see that the results are returned as shown below the paragraph. So this is about how to query Iceberg table through Presto Iceberg connector. And then with the new two tables, I may want to insert some new records into the tables, right? So here, the example is about row inversion, that I want to insert a new row into the nation table. And the values, let's say that the nation key is 25, the name is new country, the region key is 1, and the comment is comment. And then I want to verify that the row is really inserted successfully into the new table, right? So I ran a select from statement to check that. And you see that the result is returned, which indicates that the new record has been successfully inserted into the table. And this is the examples about schema evolution, that how we could enjoy this feature through the Presto Iceberg connector. On the left side here, I would like to create a new column and add it into the nation table. So the statement is alter table, add column zip with the new column is under the name of zip, and the type is varchar. And then I describe the table to verify that the new column has really been created. And the result is shown below. And here you see there's a new column zip under the type of varchar. On the right side, I want to delete the zip column. Still, it's alter table CTAS nation job column zip. And then I describe the nation table again to verify that the zip column has been successfully inverted. And the result is shown below. On the next section, I would like to introduce Beinan to talk more about the latest features of Iceberg Connector and some internal mechanisms of the latest features.
Thank you, Chunxu. I'm Beinan from Alluxio. Today I will share some new features of our Iceberg connector. Most of these features actually just got developed in the last 3 months. Actually, our community, I mean the Iceberg connector, got much active in the last 3 months. We can see quite a few engineers from all over the world, from Amazon, from Tencent, from Uber, also from Twitter and Alluxio, joining the contribution. For the first one, I think it's a very useful feature. It's called native folder for the metadata storage. By enabling this one, we can totally get rid of the high meta store. If you don't have a great high meta store, or your high meta store become bottleneck or single point failure, I definitely recommend you to try this feature. By this feature, you don't need high meta store, you don't need MySQL. You just need a storage like HDFS or S3. Then you can put everything there. No other dependencies. Just Presto plus HDFS is good enough for the Iceberg connector running. I will put more detail for this feature in the next slides. For the second one, the Baolong's team from Tencent, they enabled local cache for the Iceberg connector. The local cache here is just a local cache from the Raptor X project. In that project, we speed up the Hive tables, I mean the query on Hive tables 10 times faster, actually more than 10 times faster, just by using Alluxio's local cache. And now we just take this local cache to the Iceberg connector. We can also see this kind of improvement on our Iceberg table. For the next one, we the Xinli's team from Uber, also under me, we upgrade the version of Paquet from 0.11 to from 0.10 to 0.11 and then 0.12. This upgrade enabled us to upgrade the Iceberg version from 1.11 to the 1.12. In the Iceberg community, they officially published the Iceberg v2 table in this version. So that means after this upgrade, we can have the row level insert and deletion in our Iceberg connector. But this feature is still under development. For last one is the predicate pushdown to the Iceberg. It is from me. By this predicate pushdown, we can highly reduce the number of the files, or we can say the partitions we scanned in the Iceberg connector can improve the performance. Okay, let's go to the native catalog first. If you check the document of the Iceberg itself, you can see that actually there's 2 catalogs supported by the Iceberg. The first one is the Hive catalog, which stored some of the metadata in the Hive metastore. By using this one, that's the first catalog supported by our Presto Iceberg connector. But using this one, we still need a Hive metastore. That means we have a dependency of the MySQL database or something similar like PostgreSQL. This kind of thing can be a single point failure. If the MySQL is down, that means you cannot query any table. So Jack from AWS, he integrated the native catalog, or we can see the Hadoop catalog, into our Presto Iceberg connector. By using this, we can get rid of the Hive store, and we store everything in the file storage like HDFS. But in the Iceberg connector, we just need, because before we need a link. We need a link something, the link and the port URL to the Hive store. But now we don't need it. We just need a path to your Iceberg tables. The Iceberg connector will iterate all the folders in that folder to show all the tables there. There's some drawbacks for this implementation, but the good part is we don't need MySQL. The bad part is we can only have one folder of our Iceberg connector. Maybe we can support multiple folders in the future, but now it's just one folder. I borrowed this diagram from the RaptorX project, but it's almost the same thing in the Iceberg connector, because our Iceberg connector actually we just reuse the packet reader and the awk reader in the Hive connector. So that means every optimization we did in the Hive connector, I mean in the Hive's packet reader or awk reader, mostly we can reuse them, include our local cache. When the Presto do the planning, do the planning for our Iceberg tables, actually that's the same thing. We just pass the SQL, but for the Iceberg connector, actually we pass the predicate to the Iceberg itself, and the Iceberg will do the planning. Iceberg will split the scan job into multiple subtasks, and each task will have a path of the file we need to scan. So actually that's the same thing, just based on the file name. We do consistent hashing of that API. Now we just do some basic hashing here. We call this soft affinity. That means for the same file, it will always go to the same worker. Why we call soft affinity? Just because we have primary worker and the secondary worker. If the primary worker is too busy, we will go to the secondary worker. If the secondary worker is still busy, maybe we can go to other workers. So that's we call the soft affinity. By doing so, for each worker, for each Presto worker, they can just use their local SSD. But we recommend you to use the NVMe SSD here to speed up the query. You can keep 1 terabyte or 2 terabytes on each Presto worker. And also Baolong from Tencent, they also do something else. They can make the local cache to support multiple SSDs. You can support something like a RAID 0. You can highly speed up the I/O here. The Presto worker can just use the local data to populate the results. We don't need to, if we hit the cache, we don't need to go to the remote storage. They can save a lot of network bandwidth. It can make your Presto cluster much more stable. Predicate push down, that's a feature just developed by me. It's based on the Presto DB's connector optimizer. For the connector optimizer, it's a project, sub-project in the Azure project. It can optimize a sub-tree of your plan, because the query plan, the logical plan, or physical plan, it's a tree. Maybe you have an Iceberg table drawing a Hive table, maybe a Hive table drawing a MySQL table somehow. So here we can just collect the subtree in our Iceberg connector. If we scan Iceberg table with this predicate like the city and the age, we can try to push down this predicate to the Iceberg, because as we mentioned, actually Presto is asking the Iceberg connector, actually asking the Iceberg, the library, to do the planning, to split the task into multiple splits. Each split may be a file. So we need to let the Iceberg table know what kind of data you really need. So here we push down the predicate, something like the city, to the Iceberg, and the Iceberg can scratch the filter and the scan at the same time. They regenerate the plan with the city's name. That means we don't need, if we just partition by the city, that means we don't need to scan other partitions. And also we can use the stats of each partition to narrow down the partition we need to scan. But you may have a question: why we don't push down the edge to the iceberg? It's just because the edge here actually it's not a top level column. It's a sub column in some nested structure. We can call it nested column somehow. It's not top level. For this kind of thing, the iceberg cannot use it as a partition key, and also the iceberg's planner cannot accept this kind of predicate. So we need to keep this one still in a filter. That means we have a partial filter here. It just contains the predicate which iceberg cannot take in, and for some of the predicate can be pushed down to the table scan. It can just enforced by the iceberg itself. We don't need to do the filter in our Presto's filter. But there are some tricky part because maybe this may cause some inaccurate results. So actually, for the current implementation, we still consider all the filter passed in from the original filter. Here's some results of the predicted pushdown for this query, because for the birth month 13, it's a fake data made by me. It's only 1 rows. So here we can see without the predicted pushdown, we scanned all of this 2 million rows. But with this predicted pushdown, we only have 1 input rows. We can also see the input data is much smaller than before, and also the CPU time, everything is. We speed up the query by doing the predicted pushdown. Okay, here's some ongoing work of our Iceberg connector. The first one is the native Iceberg I/O. It's also from Jack from Amazon. Because now, as I mentioned in the local cache part, we are still using the packet reader and awk reader in the Hive connector. It's still based on our Presto's logic and data structure. But the Iceberg community is also very active. They are keeping making more new features. They are making some row level operations. They are making index. They are making more stats. So if we want to, we will always enjoy the most up-to-date features from Iceberg, maybe we need to use the native Iceberg I/O instead of our Presto's packet reader and awk reader. So that means for any new features, we can just use it without make any modification on our code, any Presto code. The second one is the materialized view. Chunxu is working on that. Recently, we have a lot of updates on the materialized view. It's mostly from the team in Facebook. They have some materialized view rewrite. They may post a blog in the future. But for here, we just focus on the materialized view in Iceberg. For the last one, actually, I'm working on that. It's the row level deletion support. Now we are still struggling on this one. Should we make this based on the native Iceberg I/O, or we should make the enhancement on our packet or awk reader? So we are still arguing about that. But anyway, I think that's a highly desired future from the community. We need row level delete and insert, which can make our Iceberg connector somehow like a OLTP. For small tables, you can just use it like a MySQL database. Okay, that's all from us today. If you have any questions, you can feel free to ask. You can type in the chat. Again, thank you everyone. It's great work. Your contribution makes our Iceberg connector much better. Thank you.
Hello. Thank you for joining this session. Any questions?
I think there's one in the Q&A session, Beinan.
Okay.
Chip asked about like where's the location of the connector, the source code in the Presto repository. Yeah, I think the quick answer to it is that it is in the Presto DB GitHub repository. There's a Presto Iceberg folder, and the source code is completely located there.
Yeah, just give me a second. Let me find a link. I think that, yeah, I got it. I think most of our code we're talking today got merged, except the predicted pushdown. That's why it's still not merged. But I got some approved from other committers, but we are still testing it because we are very conservative for most feature we are doing here. It's a super important connector, and then many companies actually they're already running some very critical query by using it. Yeah, here's the link.
Any other questions? Feel free to ping us in the channel.
Yeah, for these connectors, actually we already have quite a few features, and yeah, we're most up to date. We're catching the most new features from Iceberg, but our document, is still far behind of our features. I think maybe that's something like a next step we have to do, yeah, in the near future. Yeah. I should put this one in the ongoing work, but I forgot to make it.
Yeah, I think we are doing lots of new features for the connector, actually. Yeah.
Yeah.
Maybe that's it, I think.
Yes, I think
no questions here.
Yeah, we are also running out of time, I think. Yeah.
Okay. Yeah. So thank you, folks, for joining the session, and have a good day. Yeah.
Have a good day. Okay. See you. Bye.